Why is autonomous driving important within ELLIOT?
Yeah, so autonomous driving it's a really hard problem. So traditionally, how people solved it in this industry is to spend billions of euros and dollars into acquiring large data set at scale. But even so, you're actually getting mostly correct and clean data without corner cases. So in ELLIOT, we want to make use of these large pre-trained foundation models that have seen a lot of data and a lot of expertise, a lot of things happening in the world beyond what's usually happening on the street. And we're planning to leverage this knowledge to distill them or to use them into training better and safer autonomous driving models while still being more data efficient to compensate for the boringness that we have in the driving data, because you just drive straight and it's mostly not, it's boring. There's nothing happening most of the time unless there's something critical. And this is where we come in with the ELLIOT foundation models to take this knowledge that is not existing in the data sets that we have.
What progress has been done in using natural language and multimodal data to detect and search for road infrastructure issues?
So within ELLIOT and in this use case, we first defined this problem. Actually, we realized that it's a problem that is more difficult than it may seem, because we need to identify what's wrong in a scene. In the driving scene, when on the road. So it can be tiny details from a crack on the road, but also like a graffiti on a wall. And all this needs to be done while telling the model that it should ignore the cars, the vehicles, the pedestrians, the weather, the change of nature because of the seasons and the time of the day. So actually, we're putting into this model a complicated tasks, and we notice so far that much of the models that exist right now, be it proprietary or public, are struggling with it. So when defining this problem, we came up with a new benchmark, a new data set with annotations, where we're making the first steps towards solving this problem. And also at large, we will encourage researchers, PhDs, to study this problem and contribute together to improving this actually complicated task.
What achievement from the first year are you most proud of in its application domain?
Yeah, so we're really proud of our recent DrivoR model. DrivoR stands for driving on registers. So it's a very, very simplified end-to-end driving architecture that builds upon vision foundation models. So here we're taking a pre-trained model trained on internet images, and we put it in a pipeline where it takes information from multiple cameras at the same time. And it needs to reason and to take an action and to predict what will be the driving action such that it will drive safely. What's novel and interesting in this DrivoR model is that we simplified dramatically the pipeline. We removed all the non-interesting bits and pieces of it. It's just transformers. It has essentially three transformer blocks that they're trained together with minimal overhead. We are actually changing very little this pre-trained foundation models by inventing a new compressor representation that takes this information from every cameras and allows the model to take the decision. And we're super proud of it because we presented it recently at CVPR, and we got a very good feedback both from academia, but also from some industry labs, from car makers and players in the autonomous driving sector.